In this video, I want to look at how to interpret the values of a ratio as unit rates. Let's suppose we're making some bread and the flour to water ratio is 12:5. So if I use 12 cups of flour, I need 5 cups of water. Well, 12 divided by 5, or 12 over 5, that tells us how many cups of flour for exactly 1 cup of water. So we have 12 over 5 cups of flour per cup of water. So in this way, our ratio 12:5 of flour to water is naturally associated with the fraction, 12:5. And this tells us the number of cups of flour per cup of water. This is also known as the unit rate. So this way of thinking about the ratio 12:5 of flour to water is naturally associated with the fraction 12 over 5. So this is going to tell us the number of cups of flour per cup of water. So this is known as the unit rate of flour per cup of water. In general, let's suppose we have a given ratio A to B, relating two non-zero quantities. Then the fraction A over B is the unit rate, also known as just the rate. It tells us how many units there are of the first quantity for every 1 unit of the second quantity. So it tells us how much of A we need for every 1 of our unit of B. So let's look at examples of this. Let's suppose Rich runs 5 meters every 2 seconds and then keeps that steady pace for several minutes. I want to know how far does Rich run in 15 seconds, or in 35 seconds, or in just a general T seconds. Well, we know our unit rate would then be 5 over 2 meters for every 1 second that he runs. So in 15 seconds, he's able to run 15 groups of 5 over 2 meters. So this would correspond to 15 times 5 over 2 meters. In 35 seconds, he would need to run 35 groups of 5 over 2 meters. So we have 35 times 5 over 2. And for the general T seconds, well, now we need T groups of 5 over 2. So we have our number of groups times 5 over 2 to give us our meters. Continuing with this problem, let's consider how long does it take Rich to run 24 meters, 32 meters, or D meters? Well, we'd actually have 2 unit rates. 5 over 2 was 1, and that gave us how many meters he runs in 1 second. If we reverse that fraction, we would get that we have 2 over 5 seconds for every 1 meter. In that case, the 24 meters, well, he takes 24 groups of 2 over 5 seconds. So 24 times 2 over 5. For 32 meters, in this case, he needs 32 groups, each of 2 over 5 seconds. So 32 times 2 over 5. And then for general D meters, well, we have D groups each of 2 over 5 seconds, so D times 2 over 5 seconds.